Hey, math tutor here. These are step-by-step explanations, and I'm going to show you exactly what to write. Okay, so you have to find the derivative of g. So derivative of f is f prime, derivative of log of x, natural log of x is 1 over x. Cool, now we have to plug in 2. So to get f prime of 2, let's look at the graph. This is the graph of f prime, right? Not the graph of f. And okay, so it says, yeah, so when x is 2, y, like f prime, is 1.5. Cool, so that's 1.5. This, of course, will be a half. So the answer is 1. Except remember that you do not have to simplify your answers. So you could just write your answer like that, and that is exactly how I would write my answer. Cool, part B. So in part B, we have to find points of inflection. Now, think about it. Point of inflection of f is where f changes concavity, because that's what the term point of inflection means. But that means that would be where f double prime changes signs, right? And you think about it even more, that means where the slope of f prime changes signs. So where is the slope of f prime changing signs? Oh, and we're only looking at the interval from 0 to 3 for some reason. So, all right, I guess it would only be in this spot, right? Like right at this point is where it changes signs, because it goes from being like positive slope to negative slope. Right. So the point of inflection is at x equals 1. And you do have to say because blah, blah, blah. Like you do have to give a reason for your answer. And yeah, it's totally okay to use abbreviations like POI. The graders will know what you're talking about. And part C. So now we have to figure out where it's increasing and concave down. So if you think about it, F is increasing means F has positive slope, right? F is just going up. That means F prime has to be positive, right? Okay, so it is important to think about this in terms of F prime because that's the graph they gave you, right? So where is F prime positive? Well, it's positive here, right? And it's even positive over here. Like literally the y coordinate is positive in those places. Now, f is concave down. That means that f double prime must be negative, and that means that f prime has to have negative slope. Yeah. Okay, so where would this graph have negative slope? Well, like maybe down there, and then also like down here as well. Because it's literally going down, it's decreasing, right, in those spots. So then the question is there anywhere where it's like both? Is there anywhere where you see both blue and green? Yep, right there. So that would be from 1 to 3. So 1 to 3, and you do have to provide a reason because it says give a reason for your answer. And it is important for your reasoning to be about f prime specifically, right? You don't want your reasoning to be about f double prime. Same thing for this answer. You don't want your reasoning to be about f double prime because that's not what they gave you in the question. They gave you f prime. So talk about that. And then finally in part D, this is where we get to the crazy part. Finding the absolute minimum and absolute maximum here. I heard one AP Calculus expert say, this part will be controversial. Whoa. So let's talk about it. So to find absolute extrema, generally you do like a candidates test, or that's a way you could do it that like always works. So let's do it that way. So first step, you have to get the critical points, the places where the derivative is 0 or undefined. So these are the places where it is 0, because literally on the graph, it's 0. Like the y coordinate is 0. And there's no places where it's undefined. So those are your two critical points. Now you have to make your table. People often make tables for candidates tests. This is a big table. So I have -2 and 3 in there because those are the critical points. I also have -4 and +4 in there because those are the endpoints. You have to include those. All right. And so my table has like x as a column, of course, and it has f of x as a column. I need to figure out like a formula for f of x. This is it. How did I come up with that formula? Well, I like to think of it as like start plus integral, right? Like if you start somewhere and then add on an integral, you will end up somewhere. And you can calculate where you will end up. So that's useful because I want to figure out what happens if I end up at like -4. Like what is f of -4 going to be? Or what is f of -2 going to be, right? That's what I want to figure out. So I can calculate those like ending positions, those ending places, if I do start plus integral. So I'm starting at 3. Why am I starting at 3? Because the problem told me that 3 is a value on the function. Yes, when x is 2, y is 3. So I'm going to start at 3, the y value. The x value is 2, so that goes in the bounds of the integral. And then, okay, what are my end values going to be? I don't know what the end y value is. That's what I'm going to calculate, f of x. And I don't know what the end x value is. I get to pick that. Like I could pick -4 or I could pick -2, right? But so I just write that as x in the bounds of the integral, and I'm integrating f prime of t. Okay, so then I just have to calculate like f of -4. And I said this was f of -4, right? And f of -2, whichever one is, and it goes on and on for the rest of the stuff in this table. Whichever one is the biggest will be the absolute maximum. Whichever one is the smallest will be the absolute minimum, right? That's really hard to do here. In fact, it's actually impossible to do because there's just no way of actually evaluating this integral. You can't do the integral. So often when people ask you to do an integral, they'll give you an equation and you do like the antiderivative of it, right? They don't give us an equation here. Or often for this type of question, there's a question that's like similar to this. Like I like to call it like the graph question. There's a question that is similar to this that's on the exam every year, okay? Generally, when they give you this question, there's like shapes on the graph. There's like triangles or semicircles or squares, or look at past years. You'll see there's always a question like this, and there's like weird shapes on the graph that you can actually calculate the area of. So that's the way you would do the integral, right? There's no weird shapes on this graph that you could actually calculate the area of. These are like curves. I don't know like what the area of this shape is. I mean, you could sort of approximate it as a triangle, but I don't think the College Board wants you to do that. You're just going to get an approximate answer. So how are you going to calculate the integrals here? So what we're going to do is we're just going to sort of reason our way through these integrals. And I'm going to start not at the top of the table. I'm going to start at 3, just because I think it'll be easier. Okay, so for 3, when x is 3, that means I'm going to go up into my formula for f of x. I'm going to replace x with 3. Cool. So I have to do that integral, 2 to 3. All right. So I don't know. What is the integral from 2 to 3? Let's look at the graph. So that would be literally this area. And once again, I can't calculate this. Maybe it's like 2 or something. Who knows? But I can think about like it's positive. I know it has to be positive, right? Okay, so I'm doing 3 plus a positive number. That means it's going to be bigger than 3. So that's as much as I know about that y value, right? That's as much as I know about like f of 3, right? F of 3 is going to be bigger than 3. I even provided a little bit of a reason here, a sentence here that explains why, right? Because it's above the x-axis. That's what makes that area positive. That's what makes that integral positive, right? Cool. All right, so now let's look at this one for 4. So for 4, I need to plug 4 in for x. So get rid of that, replace it with 4. Right. So integral from 2 to 4. How would I do that? Well, let's look at the graph. So it's going to include this area, which we already thought about that area. We've already thought about that. We know it's a positive number. And then it's going to include all of that area as well. Well, okay, well, this is going to be bigger than the previous one, right? The previous one was just that. Now we got all of this extra stuff. It's definitely going to be bigger. So I can say, yeah, it's going to be bigger than f of 3, right? Because remember, this is f of 3. Now, I also put a bunch of intermediate steps here, sort of like explaining how I got there, just to make sure I would get like full credit on the AP exam. I don't think you have to write all of this with like math symbols the way I wrote it. You could probably write like 2 sentences that would explain the same thing with like, English words and stuff. But I chose to write it as math symbols. Okay, so what that means is that our area is bigger than f of 3. So right now, if I had to guess like what the absolute maximum is, I'd say this, right? Because I know this is bigger than this one, you know? Okay, so let's continue to -2. All right, so I'm going to plug -2 in for x. Okay, so let's get rid of the x. Let's make it -2. Now, this is weird because why is the top bound smaller? Right? Like in an integral, generally the bottom bound is smaller, but it's not right. It feels wrong. So what we're going to do is we're going to flip the bounds. We're now going to make the bottom bound the negative number. You can do that. You just also have to flip the sign of the integral. So previously it was like plus, right? Now we're going to make it minus. Cool. Okay, but let's think about what this integral would equal. So it's from -2 to 2. So it's like all of this area, right? Well, this is a bunch of positive area. I mean, it's going to be a positive number. Cool. So 3 minus a positive number means it's going to be less than 3. Once again, provided a reason, a sentence, but that is the logic. Okay, so now let's look at -4. So for -4, we're going to plug -4 into x. Once again, why is the top bound smaller? Let's flip the bounds. You can do that, but then you have to make it negative there instead of plus. Okay, so let's think about what the area of this region would be. So it's going to be from -4 to +2. So first we have all of this area. Okay, cool. But then you also get this area, right? And I'm shading it a different color because this is different. This is negative area because it's beneath the x-axis. Okay, so I know that this will be smaller. It's a smaller total area than the previous thing we just talked about, right? Smaller total area. So what that means is that this integral is smaller than this integral, right? So I think, wait a minute, so I'm doing 3 minus a smaller thing, right? If I do 3 minus a smaller thing, shouldn't I end up with a bigger answer? That's why I say it's bigger than f of -2. It's bigger than this one, right? This is f of -2. This answer is bigger than that one. And I even provide a sentence explaining that. I have all these intermediate steps that you don't have to write with math symbols. You could probably write it with like English sentences. But all right, there you go. So I think therefore we can like logically conclude which is the absolute maximum and which is the absolute minimum. This has to be the absolute maximum. It's the biggest thing that we saw, right? It's even bigger than that one. And all the other ones are smaller than 3. So yes, this one has to be the absolute maximum. And this one has to be the absolute minimum because it's smaller than 3. It's very small. And this one's this one's a little bit bigger. So this one has to be the smallest one. You can even write them in order of like smallest to largest if you want to be like super clear about this. But yeah, so we can conclude absolute max occurs at x equals 4, absolute min occurs at x equals -2. And the way I would write my answer is pretty much the same thing I just showed you. But yeah, this is a lot to write. Is there a shorter way of writing your answer? Probably, but we won't know for sure until we see the official solutions from the College Board. They haven't been released yet. I'm recording this literally on the day that they just released the FRQs. So as soon as they release the official solutions, I will post a link to that in the description of this video so you can compare those to my solutions. But yeah, that's it for this video. Thanks for watching.